Hi there, my name's Vince from mymatevince.com, and in this video today I'm going to show you how you can wire up your own TV plug. These are also known as coaxial plugs, a Bell-in-Lee plug or an IEC plug. They're the type of plugs that connect up the cable from the aerial on the roof down to your TV, and they give a nice connection. So basically, first thing I'm just going to quickly talk about cables. Now, a lot of the time you can get away with using cheap cables if the signal's strong, but if you've got a weak signal already, sometimes by using weak, bad cables, then that can be enough to throw the signal out, or it can start going pixelated. So just an example of a sort of a cheaper cable. This isn't the cheapest one that you can get because this one has actually got foil shield and the braiding. But if you have a look, the middle bit here is very thin. So obviously the thinner the cable, there's going to be more loss on the signal on the central conductor. So the thinner the central conductor, there will be more loss. But yeah, so that's that one there. So that is obviously, that's just a cheap like fly lead cable that you would get from your wall socket to your actual TV. Now, next cable up from that would be an RG6 cable. So this is an RG6 cable. Now sometimes RG6 cables will come with aluminium braiding, and other times they will come with copper braiding. Now basically, if it was all copper it would be better, but these cables are cheaper because they use aluminium, and aluminium is a cheaper than copper. So basically you've got the braiding there, and you've got a nice foil shield, and then you've got your dielectric there. This one's an airspace dielectric, so if you have a look on it there, you can actually see that there's holes going all the way down it, because air is actually a good insulator. Can you see that when you zoom in? Yeah. The only problem with this is, if you're using this outside and water gets into the cable, you'll find that the water can end up travelling all the way down the hollow dielectric, all the way down inside. So just with this cable here, although you do have a nice thin central conductor, so it's nice and thin and thick. Sorry, it's nice and thick, but it isn't actually pure copper. It's copper clad steel, so there's only actually a very thin coating of copper on it, and the inside of it is steel. It's going to be hard for me to show you, but I don't know if the camera's going to pick that up, but at the end there you might be able to just see, if I'm not shaking too much, you might be able to just see that it's silver instead of copper. Okay, so again, it's a lot cheaper because steel doesn't carry the signal very well. So the best cable to get, if you can afford it, is a cable which is all copper. So if I was to show you this cable here, this particular cable is Webro, that's the manufacturer, and it's called WF100 cable. So this cable here, this is, so it says WF100 and it's made by Webro. If it was a triax cable, that's another manufacturer, it would be called TX100. If it was Philex, it would be called PF100, but they all end up in 100. And I think it's because they copy the cable that was made years ago called CT100 cable. So it's a very high quality cable. And if you have a look at it here, it's all copper. So we take the sheath off and we've got nice copper braiding, and a lot of the braiding as well. And then we've got a nice copper foil, and we've got a solid dielectric here, foam dielectric, so it's not airspace, it's solid. So it's better to use outdoors. And if I show you the central conductor, it's nice and thick, it's 1 millimeter thick, and it's pure copper all the way through. So it's not copper clad steel, it is actually pure copper all the way through. So this will be the best cable. The RG6 cable will be fine if you're in a strong signal area, it will work fine. But if you're unsure, or if you're in a weak signal area, definitely use, for example, a WF100 or TX100. Use one of these pure copper cables, because then you're not going to have to worry about, once you don't want to install it all to then work out that the cable you've used isn't good enough, because it's better to use a better cable, because you can always knock the signal down. If the signal's too strong, you can get this little attenuator to knock the signal down, which is a lot easier than trying to boost the signal up. So I'm just going to show you how to connect up one of these plugs at the end So basically you normally get these in a kind of 10 pack from just the high street stores like B&Q or Screwfix, those type of places. And it comes in various parts. So if I put it down on the table now, you can see it normally has 4 parts to it. Let's get rid of all that rubbish. I'm going to be making up this end now on the good quality cable. So to begin with, we just put this sleeve on this way round, because what happens is you put this bit on the cable, then you put this part onto the cable, then you put this bit onto the cable, and then you put this end bit on and you screw it all together. And then to get a proper job, we're going to solder the middle pin, and we're also going to solder the braid on to this little clamp here. Now, it isn't really necessary, but it all helps. So if you haven't got a soldering iron, you can still make these plugs up, but it all helps. So what we're going to do to begin with is we're going to cut the outer sheath, and we're going to leave it nice and long because we can always cut it back. Now I just want to cut the outer sheath. I don't want to be cutting much of the braid on the inside. So I've used my tool now. Again, you can use your Stanley knife or another pair of cutters to score around it, but I've got the cable cutting tool. Again, these are only these are about £3 from Amazon, so they're not expensive, so it's well worth investing in them. So I've pulled that off there. Okay, so we've just got the sheath off, and now what we're going to do is we're going to put these wires back. Now some websites will tell you to put this bit over the whole lot of it, and then you can put the braiding over this bit when it's down here. But unfortunately, with these particular plugs, this cable's quite thick, and with these plugs, this bit here, it doesn't actually, there's not enough room to do that. So this will give you an equally good signal. So what I'm going to do is I'm just going to make it into a bit of a kind of pigtail down here, like so, like that. And we're just going to also take the foil off now as well. So get rid of the foil. Sometimes the foil comes off really easy, other times it can take a little bit of working round. Okay, so we've taken the foil off now, and we've got the braiding. And make sure the braiding's gone right the way to the back, because the most important thing is that we don't get any of this braiding or the foil touching the central conductor, because if we do, it's going to short out, it's not going to work. So, sorry, I forgot to put that on earlier, so we'll put this one on here now. Okay, I'm now going to put this on like so. Okay, so it's going to be like that. And now what I'm going to do is I'm going to wrap this around underneath them, but I am just going to leave one of them out at the very end to just solder on to the end bit here. Okay, but we're going to do that at the very end, we're not going to do that now. Right, so what we need to do is we need to leave about 2 or 3 mil of foam dielectric here, but we want the central conductor to start at around here. So nice and gently, I'm going to just go round and score it. Again, you can use a Stanley knife for this, but you want to do your best to not actually damage the central conductor at all. So if you find score marks on the central conductor, then I would cut back and start again. But I did that nice and gently, and I didn't even get quite as far as the metal. Okay, so that's what it's going to look like there. Now, if you're not going to solder it, what you're going to have to do is you're going to have to put a little bit of a kink, just like that. So when you put on this bit here, it will do a better grip, because the problem is, if you have a look in there, the central conductor's a millimetre, and this part in here is probably, maybe, I haven't measured it, but maybe 1.2 or 1.3, but there's a bit of play there, so it's not going to give you a very good connection. That's why we're going to solder it, but a lot of people don't solder it, but by putting a kink in it, it's now made the contact against the actual central pin. So if you're not going to solder it, definitely put a kink in it, but we are going to solder it. So I'm not too worried about making sure that the kink is good, because we're not going to solder it. So basically, yeah, if you weren't going to solder it now, you would just push that on there like so, and then you would just do up this bottom bit, nice and tight, and then you would cut off the wire flush with that there, and then that will make your plug up. But we're going to solder it in this one, so I'm going to take these bits off. Now, I'm just going to cut the video there while I heat up the soldering iron. Okay, so I've got the soldering iron heated up now, and I'm just going to solder this tiny bit of copper braid here, which is the end of the pigtail I showed you earlier, onto one of the copper lugs. I'm just going to heat it up to begin with, and then just tap the copper on it, the solder onto it. Okay, so that's that bit done. Now, you only want a very small flat bit of solder onto it. You don't want a big mountain, because otherwise you won't be able to screw the plug together. Right, okay, so if you just zoom out a little bit. So now we're going to put this bit on here. We're going to make up the plug again. So you can see there, if you did a huge mountain, or if you were to solder it up too high, then when you pull the plug on, when you push this part of the plug onto it, then right now I can't push it down any further, not because of the solder, just because it's butted up to the inside bit. So you need to do it quite near the bottom of the lugs. So I'm going to screw this together, and then we're going to put a solder down the inner tube here, the central conductor. Okay, so that's on nice and tight. Now, it would be better if I had a proper stand for doing this, but I haven't. Okay, so I'm not sure if you're going to be able to see this bit now from there, but if you zoom into the top bit here, hopefully you'll see the solder go down it. So I can't keep it on for too long, because what will happen is it will melt the plastic white on the inside, the white plastic. So I just need to put it onto the copper central conductor, and then I'm going to just tap the solder and hopefully it will flow down. Right, I think that's done it. Yeah, so just have a look down and make sure that it has actually filled the void, and then what I'm going to do is I'm just going to cut off the excess, because obviously we don't need the whole centre conductor coming all the way through, so just cut that back to the plug. And now if you have a look closely there, the solder has flowed in between the central conductor and the actual pin itself, so now it's filled up that void. So that should give us a nice good connection now, because we've got the braid soldered onto the outside of the plug, and then we've got the copper conductor soldered to the central connector. So are you going to see a difference between doing it this way and just kinking it and putting it on? Not necessarily, not if you're in a strong signal area. It probably won't make a blind bit of difference, but this is the proper way to do it. So if you are, like, I've got a lot of trees out the back here, so I struggle with the signal in my house, and by doing little things like this, it can make the difference between certain channels working and not working. And lastly, just to test it, it's just a very basic way of doing it, but I've got a little continuity meter here, and when I touch the wires together, it makes the noise. So if I go onto the outer plug, and the outer plug of this side, it's in contact with each other. If I go onto the inside, the inner conductor and the inner conductor is in contact. And even if you haven't got the plug on that side, you can still test for a short by just going on the outer conductor and the inner conductor, and if it's not making the noise, you know it hasn't shorted together. If one of those braids has touched the middle conductor, then it would be shorting out, and then it would be making the circuit, so you would hear the beeping. Okay, so I hope you found that video useful. Please give it a thumbs up if you like it. Please subscribe for more how-to videos. Okay, that's it. Take care. Bye now.